Chapter 10, Functions. 10a is about relations and functions, and we're going to do a little bit of review with some vocab. An ordered pair is a pair of coordinates written in the form x, y, and it's used to locate a point. Our Cartesian coordinate plane is a plane formed by the intersection of the x-axis and the y-axis. Quadrants. The four sections of the coordinate plane numbered with Roman numerals. So you've most likely seen, we know that this is our coordinate plane, and it's unit section 1, 2, quadrant 3, and quadrant 4 going counterclockwise. Okay, so we always start in the real world quadrant where everything is positive, and then we go counterclockwise. All right, the next vocab word is relation, which is the set of any ordered pairs on their Cartesian plane. So just a list of ordered pairs. They could have a pattern to them or not. The next vocab word is domain, and it's the set of all of possible x values in a relationship. Okay. The range is a set of possible y values in a relation. And we'll talk about what it means by input and output in a minute. Finally, a function is a special type of relation in which each x number is paired with exactly one y number. And below we have some mappings which show how the domain and range are paired in a relationship. If necessary, pause your video to fill this in. When you're ready, we'll move on. So here's my first one. It's a relation example. And we're going to go ahead and fill in. This is for the domain, and this is for the range, so my x and y values. So my x values, I'm going to put them in order. I have -6, 2, and 5, and you don't have to put them in order, but it's convention. Notice that I just list the 5 once, even though it showed up twice, and then for order, and it's -3, then 3, 7, and 10. So we started a mapping, but a mapping actually shows the relationship between the numbers. So notice the input, or the x for the first one of 2, has an output, or y, of 10. 5 can spit out 7. And when I mean spit out, we're talking about a function machine, but we'll talk about that in a minute. Or 5 has a corresponding y value of -3, and lastly -6 goes to 3. So that is a mapping. Sometimes they'll give you the points and ask you to draw the picture, or sometimes they'll give you the picture and ask you to list the points. With this, okay, this is a relationship and not a function because 5 has 2 separate outputs. So it's a relation. Okay, a relation could be any list of points, but it is not a function, which is a special type of relationship. Or sorry, relation. And what we can do is we can go ahead and graph these points. And I'm going to do that over here. You do it. I paused it and I went ahead and graphed it. I had to extend my number line a little bit. So for example, I graphed -6, 3. I went back 6 and up 3. And I want you to notice this is a relation because these two lines fail the vertical line test, which we'll talk about in a minute, or these 2 points. They're on the same line. So for this x at 5, it could go up here to 7 or down to -3, and that is a problem. So that's a picture of that relation. Here's another example. Let's go ahead and fill it in. So my domain consists of 2, 3, 4, and 8. Those are my x's. And my range consists of 3, 4, and 9. And then we're going to look and see how they are lined up. Well, 2 goes with 3, 4 goes with 4, 3 goes with 9, and 8 goes with 9. In this case, it's a function, but because even though 9 is shared, each x has exactly one y. 3 goes to 9, and 8 goes to 9. So it knew that 3 pairs up with 9. There wasn't any ambiguity. You went back up here. We don't know if we're talking about a 5, if it's supposed to go to -3 or 7. Again, you could graph this, and I'll let you do that yourself. And what you'll notice is there won't be any that share the same x value. Okay, so there's my picture, and you should be able to graph that. Relations can often be expressed as an equation. And we have talked about a function machine. Okay, and so not always with an equation that's a function, but oftentimes with an equation that's a function. We have the function machine where you put what's going in, you put the domain in, and it spits out the range. Okay, and some function machine f of x, and oftentimes the equation is what's in the middle. So maybe the equation is 2x, y equals 2x. So if you put it in x of 3, comes in the machine, 2 times 3, and you get out a 6. And so this equation is like instructions to your function machine, or whoever's trying to figure out, they may know the domain, but they want to figure out the corresponding range value. Okay. We want to test to see if a relation is a function. There's a few options. The first is the substitution of any x value results in one and only one y value, like we showed up above, where we had a 5 and it had 2 separate y's. That doesn't work. So we could just test it, maybe pick a few x's. So we have x and y. If we plugged in a 0, negative 3 times 0 plus 7, and it would just spit out a 7. If I plugged in a 1, negative 3 times 1 plus 7, which would spit out a 4. Or maybe I plugged in a 10, negative 3 times 10 is negative 30, plus 7 is negative 23. Can you think of any numbers that you'd plug in here and 2 numbers would come out here? I can't. So this is a function. And frankly, this is linear. So except for the undefined lines, linear are usually functions. Okay, and we could go ahead and graph this. It starts at 7 and it's down 3 over 1. So 1, 2, 3, 4, 5, 6, 7, and we're going to go down 3 over 1, down 3 over 1. So here's my line. Notice that it's going to pass the vertical line test, which is if I had run a vertical line all the way through it, it only touches this red line, or the function, at one spot each time, because each x only has one y to go with it. Okay, another example would be this quadratic. You could go ahead and plug in x and y's. If I plugged in a 0, well, let's see, this would be 0 squared plus 2 times 0 plus 5, and I would get out a 5. If I plug in a 1, I'd get out an 8. A negative 1, I'd get out a 4. And I can't think of any x that I could plug in that would give me more than one y. So that's also a function. If we were to graph it, okay, we know that it's going to go through 5, 0, 1, 2, 3, 4, 5, 0. And it's going to have a vertex. I'll just tell you it's going to look like this. Okay, it's at negative 1, 4. And again, it passes the vertical line test. Okay, and we'll talk about how to graph those again later. Right now, you could just put them in your calculator or make a more complete table. Here's one that doesn't work. Okay, this one is not a function. It's just a relation. It can make a bunch of points and list them out, but it's not a function. And here's why. We put in our x and our y. Well, I've put in x is 0. Let's check it. So that gives us y squared equals 0 plus 4. So y squared equals 4. Square root both sides. And if you do that, you're going to get y equals plus or minus 2, because 2 times 2 is 4. And negative 2 times negative 2 is 4. So pretty much, automatically, you have 2 different y's for one x. We could try the same thing with 5. Y squared equals 5 plus 4. So that's y squared equals 9. So it's going to end up spitting out square root negative 3 and 3. I'm going to delete that work there. And you'd get negative 3 and 3. And the other one you'd get plus or minus 2. if we were to go ahead and graph that. Okay, and let's do one more. Let's see, at -4, we'd get y squared equals -4 plus 4. So y squared equals 0. Well, the square root of 0 is 0. So at -4, it's actually 0. And now we have enough to graph it. So at -4, it's 0. 1, 2, 3, 4. -4 is 0. We also know that at 0, it's at 2 and -2. So at 0x, it's at 2 and -2. And at 5, it's at -3 and 3. 1, 2, 3, 4, 5. It's at -3 and 3. So this also looks quadratic. It is a parabola, but it's on its side. And it fails the vertical line test. So if I had to run a line through it, notice that it touches that 2 spots. So it's not a function. And this one is a function. Okay, so you can just plug numbers in and see if you can make it fail, or you can graph it. Okay, and we're going to go ahead and look at page 310 in class. Section 10C, different notations with domain and range. Well, I'm going to wait and have that on the next video.